Hey everyone, let's solve problem 2b. What is the fraction of power absorbed in terms of sigma and omega? So we have to find what is the fraction of the absorbed power. So we in 2a we found that the fraction of the power reflected R is given by mod gamma square, which is equivalent to uh, eta 2 minus eta 1 divided by eta 2 plus eta 1 whole square. Now we have to find the fraction of the power absorbed. So if the fraction of the power reflected is R, then fraction of the power absorbed A is equals to 1 minus R, which is equals to 1 minus mod gamma square. So how do we solve this? So we already have an expression for eta 2 from 2a, which we can use. We then substitute that in gamma and find the expression for gamma mod gamma square, and then finally find a is equals to 1 minus mod gamma square. We found the expression for eta 2 in 2a to be equal to square root of mu naught by epsilon minus divided by minus j sigma by omega epsilon. We could simplify this in another way, and I would prefer you simplify it the way I show it here rather than the way I showed it in 2a, as let's write epsilon as epsilon naught epsilon r. So this would become square root of mu naught by epsilon naught epsilon r divided by minus j sigma by omega epsilon naught epsilon r, which is equal to, we know that square root of mu naught by epsilon naught is eta naught, so we write it as eta naught square root of 1 by epsilon r. We send the minus j to the numerator and write it as j, and omega epsilon naught epsilon r also goes to the numerator divided by sigma in the denominator. Eta naught square root of j omega epsilon naught divided by sigma. So I would prefer you use this expression for eta 2 and find the value for a in terms of omega and sigma. Problem 2c states that for the case of large conductivity sigma such that omega epsilon naught by sigma is very less than 1, derive a simple expression for the fraction of the incident power absorbed by the conductor. So now we know what is R, we know what is gamma, we know what is A. So what they're asking us to do is find or derive a simple expression for the fraction of the incident power absorbed by the conductor. We've already found what A is in terms of eta 2 and in terms of sigma and omega. Now make sure that omega epsilon naught by sigma is lesser than 1, which means any expression which has 1 plus omega epsilon naught by sigma could be written as 1, or 1 plus square root of omega epsilon by sigma could be written as equal to 1. So make these simplifications and obtain an expression for A and substitute the value of omega and sigma given in the problem and find the value. I think ultimately you should get an expression which is 2 root 2 omega epsilon naught divided by sigma whole to the power half. So it will be 2 root 2 80 gigahertz. Epsilon naught is 8.8 into 10 to the power minus 12 divided by 2.98 into 10 to the power 7 whole to the power half. So the value is going to be 4.36 into 10 to the power minus 4. Thus it indicates it's a very good reflector. So make sure you get this answer at the end. The expression should be equal to this one. Thank you.